Hello, this is Paul Browning from Freedom Hygiene and welcome to Tracking Down and Eliminating Listeria Monocytogenes Part 2. You may remember in the last video, using cranberries and a lemon jelly, we demonstrated how the scientists in one of the Madrid universities discovered that the Listeria was able to burrow underneath preformed biofilms of Pseudomonas fluorescens and to live quite happily underneath that preformed biofilm. And we explain how that biofilm gives the Listeria protection. So not only can Listeria produce its own biofilms even at low temperatures, but it can also collaborate with other microorganisms that produce excessive amounts of biofilm. And in fact, the actual presence of Listeria within that Pseudomonas biofilm encourages the Pseudomonas to produce even more, overproduction of the biofilm. So having established that, what I'd like to do this week is to look at the common hiding places where we can expect to find Listeria. And the first thing I want to say is that floors and drains probably will have the largest population not only of Listeria but of any food pathogen and food spoilage organism. And what we want to be careful is to identify any poorly sealed or damaged wall to floor joints, or where we have drains, inspect the joints between the drain and the floor. But very often what we find is that those joints over the years start to give way. We start to find gaps, and it's in these gaps that Listeria can populate, can form a biofilm, or as we've seen, Listeria could go into there if there's a Pseudomonas biofilm in there, and it could worm its way in to the base of that biofilm, giving itself the very best of protection. Damaged floors, any cracks, any holes or any gaps, and what can happen is quite serious, because as the biofilm starts to grow on the surface where we've got cracks, holes or gaps or gaps in the joint, by capillary action those biofilms will actually worm their way underneath surfaces and even up vertically onto the back of wall cladding. So we've now got a biofilm that we can't get to. We just see the edges of it in the damaged areas of the floors or drains. Associated with floors and drains, we think of people walking across, so we want to be careful that our boot cleaning management system is in order, and also make sure things like trolley wheels and the underside of portable bins, the underside of pallet trucks, or anything that's wheeled across the floor which can pick up that biofilm and transfer it from one department to another one, even from low risk to high risk. We want to make sure that everything is scrupulously clean and biofilm free. So floors and drains. Now, the next area that we want to look at would be processing equipment, and that too has certain clues as to where we're going to find Listeria, if we're going to find it at all. And with modern processing equipment, as I mentioned earlier in a previous video, it's too intricate, too complex to clean and disinfect using conventional detergents and methodology. Simply put, foams won't hang in there long enough. We may not be able to get foams into very, very tight spaces, and if we do, it's not going to sit there for more than maybe a few seconds, or at the very best a few minutes. Secondly, why we have a problem is that the hygiene window gets narrower and narrower. I can remember a time when I first came into this industry that night hygiene would probably be a 12-hour shift. Very often now it's half of that, or in some cases less than half of that, particularly in busy periods like the build up to Christmas, depending upon the kind of food or beverage that we're involved in producing. But as the hygiene window gets narrower, as processing equipment gets more intricate and more complex, and where adequate dismantling of equipment is not an option because of the time that it takes, we're going to find biofilms occurring more in processing equipment now, more than ever before in the past. So where can we expect key biofilm sites to be found in processing equipment? Well, just about anywhere. But here are a few which I've found over the last few years are common places for biofilms to be found. First of all, in niches like Grasselli slicers, which I've mentioned to you before. The combs and the knives are so intricate. There is so much involved in that machinery which does a tremendous job of doing what it's supposed to do, which is slicing meat products slice after slice after slice to a precise thickness and conformity. But the problem we have is that we can't dismantle it every night to be able to clean it with conventional chemistry. Secondly, poorly drained open equipment. If we have pools of water left on open equipment, that can encourage the build-up of biofilms, as can poor welds, any rough surfaces, poor welds or worn fabric on conveyors. On conveyor belts, on the food contact surface, we have that nice, shiny, waterproof surface. On the underside, it's more of a rough feel to it. And if we look along the actual edges of a conveyor belt that's been in use for some time, we may find there are little bits missing or little bits are frayed. And if we spray, for example, Biofinder along that edge of the conveyor, very often we will find a biofilm, and within that biofilm we could find Listeria Monocytogenes. Covers and guards, again, may not be removed every night for night hygiene, but I suggest you take off covers and guards from time to time and have a look at the back of those, where we will see whether we need to do some additional cleaning. So that's processing equipment. Also, cleaning equipment is another hiding place for Listeria. Back in 1990, Camden BRI showed that in their survey of food premises, up to 47% of cleaning equipment tested was positive for Listeria. Now that's quite a statistic. So check squeegees, check hose gun handles, check hose nozzles, check floor scrubbing machines, and not forgetting soap dispensers and electric hand dryers. All of these can contain biofilms which can contain Listeria monocytogenes. But it's not just Listeria that we're bothered about here. It's any organism which is going to have an effect on the food, or if it was consumed, could cause illness. And finally, not forgetting chillers, freezers, air handling systems, perfect Listeria hideouts. Why? Because Listeria can survive at -5. Chillers and freezers are cold and wet. And of course, in those temperatures, Listeria faces less competition from other microorganisms. So be on the lookout for water build-up inside air transportation ducts, and make sure that you have a robust programme for the regular checking for biofilms in chillers, freezers and air handling systems. So we now want to talk about how to eliminate Listeria. Quite simple. Once we've find out where it is, where is it? We can find out where it is by checking where the biofilms are. We then introduce an enzymatic shock treatment to remove the biofilm, and then integrate a preventive treatment with enzyme detergent technology, say on a weekly basis, not replacing existing conventional chemistry, but being integrated, say on a weekly or monthly basis as part of the routine program. And then we're considering other technologies such as new terminal disinfectants based on benign, eco-benign ingredients. We're looking at UVC all the time, looking for more effective ways, innovative ways to eliminate Listeria. So that's all this week. Next time, how long does a biofilm take to grow? And how do I know that I have a biofilm problem? We'll answer those questions next time.